Okay, so by now, this is section 9.0, the nets notes. By now, you've had enough time to at least look the shape over. Does anyone want to tell me how many cubes they think are here? Hannah? 24 is correct.
What? What? Nuh-uh. Same.
Now, when you're counting cubes, you're counting this as one cube.
What?
I think some of you are counting squares instead. So maybe you have the answer for part B. Okay, so that is one cube, and there are 12 on top and 12 on bottom. Okay, pardon my very bad looking cube here. Okay, now how did you get the 24, Hannah? Is there a method you used? Oh, okay. Yeah. Did anyone do something similar? Counted how many they saw on top and then just doubled it because the bottom layer was the same. Okay. There's another way. Now it's the same exact way, but instead of counting the number of cubes on top, you could have said that there were 3 in a row. There were 4, or maybe 3 rows, 4 columns. You see what I'm saying? And that's how you get 12. And then once you have 12, you could then multiply that how many layers it has, which is called the height, which is 2. And if you multiply 2 times 3 times 4, which is those side lengths together, you get 24. You did that last year. Length times width times height. Remember doing that last year? Length L times W times H. When you count the number of cubes inside of this prism, you're finding the prism's volume. And volume is, again, something you did last year, and that's the formula you would have used, is length times width times height. And that formula works for rectangular prisms. Volume is cubes. How many cubes are there? Even if it's like a circular shape, you're still counting the number of cubes. And so when you label your answer for a volume problem, you'll use units, inches, meters, yards, cubed instead of squared. Now, volume, we're going to put off for about another week or so. We're going to look at something else first. So I heard some people saying 52. 52 is the number of squares there are on the outside of the shape. 52 squares. And so you can count, there are 12 squares on top. And so we can also assume there's going to be 12 on bottom. So bottom and top, we'll say 12 plus, what's 12 plus 12? 24. On the front side, there are how many squares? 8. So we can assume the back side, we'll say front slash back. There's also 8. What's 8 plus 8? 16. And then on the right side, there are 6 squares. We can assume also 6 on the left. What's 6 plus 6? 12. And you add those together, and that's how you get 52. Or that's, if you got 52, that's how you would have done it, right? So 52 squares, that's called surface area. Now, on the test you guys took yesterday, how do you label area problems? Square units. Yeah, that's why we counted squares. So because we're counting squares, we would say 52 units squared if I was labeling this on a test, right? Or inches, meters, whatever it is. Whereas volume, you were counting cubes. Is it easier to count squares or cubes? Definitely cubes. It's going to be much easier for us to find the volume of these shapes than it is for surface area, which is why I'm starting with surface area. We're going to do the hard one. We're going to do the hard one first. Now, I don't think it's that hard. It doesn't take me that much time to figure out there's 52 squares here, especially if I just add and do 24 plus 16 plus 12. But this is what we're going to start doing tomorrow. Finding surface area, which, by the way, if we are not in school tomorrow, I will hold a Zoom because this is a lesson. That Zoom will be from 9:30 to 10 like it always is, and I will record it as well, but better that you be there and actually be live in it, so you're part of the lesson instead of watching it later. And so I'll send all that information out to you if we have an e-learning weather related day tomorrow, and if not, then we'll be in here doing it in class. Okay. So more on this to come starting tomorrow. We're going to talk about nets today, though. A net is a two-dimensional drawing of a three-dimensional figure. Nets can be used to find surface area. Nets can be used to find surface area. If I take a shape and break it down and lay it flat, that's not going to tell me how much space is inside of it. It's going to tell me how much space is around it. That's surface area. And you might be thinking, wait a second, I thought area was the space inside of a shape. It's the space inside of a two-dimensional shape. So if I lay it out flat, two-dimensional, there's your surface area. The space inside of a three-dimensional shape is called volume. Okay, like if I fill a pool up, and I'm talking about the number of gallons in that pool, I'm talking about its volume. Okay, if I'm just like painting it blue, isn't that like the traditional color of the side of the pool? That would be surface area, right? If I'm putting a present in a box, I need to know its volume. But if I'm wrapping that box with Christmas paper, I would use surface area. Okay, I don't put the paper in the box, I put the paper around the box. Well, yeah, people don't typically measure and get and cut off the exact edges and then paste them onto the side. You just wrap it and use a lot of extra, right? Use a lot of extra paper because it's easier to do that than try to cut out all the sides and try to get it perfect. So, all right. So nets are used for surface area, not for volume. Now, prisms, our next vocab word. Prisms, you guys have heard this word before, have two parallel congruent bases. The lateral sides are rectangles. Now you guys have a warped view of prisms because you probably have only looked at rectangular prisms. There are lots of different types of prisms. We're also going to look at triangular prisms. We're going to look at circular prisms, which have their own special name, cylinders. There's pentagonal prisms, hexagonal prisms, heptagonal, octagonal, nonagonal, decagonal, undecagonal, dodecagonal prisms. They all exist. And it goes on. You can keep adding sides if you want to. Now, prism means something special, though. When you hear the word prism, there's two things you are guaranteed to see on your shape. If it's a prism, it's going to have two bases that are congruent and parallel. Now, we know what parallel means. They're never going to intersect, right? They're same direction. What does congruent mean? Anyone know what that word congruent means right there? Can you give it a shot, Michael? They don't meet up. So they're parallel. So they'll actually never meet up. Okay, these particular bases. Yeah, congruent doesn't mean they'll meet up. What do you think, Andrea? It means what? Okay, so sorry, mathematical definition of the word. You might have looked up a different definition. Lucas, what is it? There you go, identical. Yeah, the word congruent means equal measure. Now, the reason they don't just say equal is because long time ago, when this stuff was first being discovered, not by us, but by the Greeks, right? They were very good at like math and philosophy and stuff like that. They didn't have a word to show that two objects were the same. They had a word to show that two number values were equal. 33 equals 33, right? We know that. But if you were going to say two buildings were the same, or two objects, whatever they were the same, use the word congruent. It means the same thing, but it's a geometry term talking about shapes instead of numbers, okay? So it means they are the same size, exact identical copies, right? So two congruent bases means they're parallel to each other, that they are parallel, it says parallel, and then the same exact size. The other thing you're guaranteed, two bases, you're guaranteed to have the other sides all being rectangles. Now, again, you have a warped view of a prism because you've seen rectangular prisms. You're like, wait a second, they're all rectangles. That's because the first word in front of the word prism, rectangular prism, describes what the bases will look like. If I told you the base is a rectangle, all the other sides are going to be rectangles because that's true for all prisms. So they're all rectangles. Okay, but there's triangular prisms and octagonal prisms and whatever shape you want to be as your base. Okay. Now, by definition of base, meaning that they're the same size and they're parallel, they'll never intersect, you could really say that any side of a rectangular prism is the base. Every side, so for example, the front side here on this rectangular prism, which we're going to fold some up here in a moment, isn't that the same as the back side? Yeah. Well, what if you said, oh, I want the top to be the base? Well, isn't that the same as the bottom? Because it qualifies. The right side would qualify as a base because the left side is also congruent, right? So that works. You could call any side you want to be the base on a rectangular prism. Okay. Here's another example of a rectangular prism, pizza box. How many of you guys like unfold your pizza boxes and lay them out flat when you're done with them after you shake all the crumbs out? Because yeah, you want to do that first before you get them all over the kitchen floor. Okay. Did you do? Fold up easier, maybe a little bit nicer in the trash and throw it out. When they get shipped to the store, these pizza boxes are actually flat, like the shape you see on the right side there. They're in net form. The reason for that is because if you just stack a bunch of pizza boxes on top of each other, first of all, they wouldn't ship very well because I'm sure the stacks would topple over, right? Also, the weight on the bottom pizza box is probably going to crush the bottom pizza box, okay? But what they'll do is they'll saran wrap these. They'll get like a stack of 50 of them, and then you just carry them into the store. And then so if you work at a pizza place, at some part of your shift, your job is going to be to unfold pizza boxes so that they're ready when the pizza's out. You don't have to unfold it then. You can put it into the box that's already been folded up. So they come shipped like this, and then you have to unfold them and get them ready. Yes?
When I was younger, I used to help my uncle like, put them together.
Really? Okay. So you have some experience with this.
Mm-hmm.
How long of a process does it take to fold it up, put it together?
Like 30 seconds.
Like 30 seconds per box. Okay. Does that sound about right? About 30 seconds, you get one of these put together. Okay. I'm going to show you a clip of in 30 seconds, somebody get about 13 of these together. Okay. Maybe you've seen this guy before.
I've seen that.
This is the Domino's pizza guy.
Yeah.
And he became famous really like a couple years ago. I saw some commercials where the guy's like a general manager now at one of the Domino's wherever he lives. But he started off just like everybody else starts off. Yeah, working just, the normal hours, and part of his shift was folding pizza boxes. And so he decided he was going to get really good at that. Now, if you, again, have any experience doing this, you know that 30 seconds per box is probably pretty normal for a laid back kind of. This guy is doing one about every 2 seconds. 2.5 seconds, maybe 3 seconds. Okay. So that's a guy that took his job seriously, right? And I don't know, maybe, I don't know how it works. I've never worked at a pizza place. Maybe they're like, hey, before you take break, you need to get 50 of these folded up. This guy's like, all right, 2 minutes, I'll get 50 of them. And then he's got a longer break. I don't know. I don't know how it works. Or he just decided he was going to do it as fast as he could and literally like whipping them into prisms from what we don't really think of them as prisms, but they are. We think of them as pizza boxes, but they're rectangular prisms. And so they start off like that, and then he folds them up very quickly into what you see with that nice looking tasty pizza inside of it, right? So that's ready when it comes out of the oven, goes in the box, and then it's ready to go. Yes. Awesome. All right. So rectangular prisms, let's talk about them. Rectangular prisms have how many faces? 6. there are 6 faces. There will always be 2 bases, 2 rectangular bases, and that leaves 4 what are called lateral rectangles. The word lateral, for those of you who do like basketball, for example, if you talk about lateral movement, you're talking about side to side, right? So sides, lateral means sides. So we have 2 bases, and then all the other lateral sides that connect the bases are all rectangles. So if the bases are rectangles and all the other sides are rectangles, then you're going to see nothing but rectangles here. There are 6 of them. So you find the area of 6 rectangles. Surface area, the definition of surface area is literally the area of all the sides added up. So those of you that got 52 squares on the first problem we did, you're good at surface area. You don't have to unfold it. You don't have to unfold it to actually do. Now, I think it's helpful. I mean, that could have been a shape you could have seen on yesterday's test, right? The composite area. Yeah, I think it's helpful when it's unfolded, but I don't have to unfold it to do the surface area. If I know that the top side is 4 by 7, and 4 times 7 is 28, I can then double that because the bottom side is going to be the same. If I know the front side is 7 by 3, that's 21, I can double that to get 42 because I know the back side is going to be the same. And then for the right side, left side, I guess, 4 by 3 is 12, double that, and you've got the area of the right side as well. And you just add these areas together. And so really not a difficult problem to do. 28 plus 28, 56. 21 and 21 is 42. 12 and 12 is 24. You add that together, you're getting 122 squares. Okay? That's what we're going to do tomorrow. We're going to look at the surface area of these shapes. So you can use the net. It's kind of nice because you can write all the areas inside, or you can just use the prism. All right, moving on. We're also going to talk about triangular prisms tomorrow. Triangular prisms have how many faces? More than 4. They have 5. You can see them, all of them. You can see right there in the net of a triangular prism, kind of looks like a rocket ship, right? Because you got the triangle parts that maybe look like wings. I don't know. So you got 5 faces. Because it's a prism, you're always going to have 2 bases. Because it's a triangular prism, those bases are going to be triangles. And because it's a prism, all the other sides are still going to be rectangles. So there's always going to be rectangles on a prism, but they're not always all rectangles. Triangular prism, you have 2 triangles, your bases. So I cannot tell you that the base of this prism is the bottom side. Base does not always mean bottom. That's not what it means to be a base. I just told you what it means to be a base. You have to have a parallel partner side that's the same exact size. There isn't a parallel partner side on the top. So the bottom side can't be the base. You can say, what about the 2 rectangles on the left and right? They could be the same size. Well, first of all, I don't think they look like they're the same size. And also, are they parallel to each other? So the only sides that qualify as bases here are the front and back triangles. So this is a triangular prism. To find the surface area of a triangular prism, you have 1 less side to do. You find the area of the, they started with the bottom. Sure, we'll start with the bottom. The bottom side is 12 by 8. Maybe you can see it better there in red, 12 by 8. That's 96. You find the area of the, then they did the front and back triangles. Now remember, the triangles have a half in their formula, 1/2 BH. So that to find the area of the triangles, they said 12 times 5 is my base and my height. 12 times 5 is 60. And then divide by 2 because it's a triangle, so 30. And there's 2 of them. So I guess double it again, you're back to 60. You got both triangles now. But I don't necessarily need to look at it like that. I could actually just use the, I mean, nets are helpful when you have it, but I'm not going to take 5 minutes drawing a net just so I can find surface area when I can see clearly here that this triangle has a base of 12 and a height of 5. That's all I need to know. Then they did the side, one of the side, the top rectangle, I suppose you'd say, that's 13 by 8. 13 by 8, right there, you can see it's 8. That's 104. Then they did the right side rectangle, and that's 8 by 5, and that's 40. And then they just added all those together. Same thing you did yesterday when you did composite area. You found the area of each shape, and then you just added them all together. Okay. The last shape we're going to look at, this will be on Monday, is a cylinder. Cylinders get their own special section because they're our newest shape and they've got circles and we just learned how to find the area of a circle. Cylinders have how many faces? 3. Fewest number of faces you can have on a prism is 3. That's a cylinder. That's because circles only have one edge, so they only have one rectangle coming off. Because it's a prism, it still has 2 circular bases. They are circles. And then you have 1 lateral rectangle. Yeah, you did. I watched you. Watched your mouth open. All right. So I would find the area of these 2 circles. Right? And then I have a rectangle. Now, they don't tell me how wide the rectangle is or how long it is. How long do you think that rectangle would be? 24? Not quite. It's close, though, actually.
30.
Not quite 30.
20.
What's this? Not 12.
26.
None of you are right
21.
because it's going to have a decimal in it.
24.1.
Okay, so first of all, someone in the other class said they thought it might be 8. And so the reason I think they said 8 is because the diameter of the circle is 8. You guys see the diameter being 8 here? Okay, here's the problem with that. If this is drawn to scale, and I think it's pretty close, if that's 8, then there's no way the length of that is the rectangle is 8. But 24 something, 25 maybe, just a little bit longer than 3 times that. Can you think of a number that's really close to 3?
2.
That we've used? Huh? 3.14. If you take the diameter of the circle, which is 8, and you times it by pi, do we have a formula that says diameter times pi? What is that formula? Circumference. The circumference of the circle is the length of the rectangle. Because think about that, rectangle has to wrap around the circle, right? So if I can tell you how round the circle is, I'll tell you how long the rectangle is. Think about when you unroll paper towel or toilet paper, right? It wraps around, usually for toilet paper, it's not one sheet, it's usually a couple sheets, right? But it's when you unroll toilet paper, it's rectangular, even though it's, wrapped in a circle. I can take a rectangle and I can make it look like a cylinder just by folding it up like that, right? So when I unfold it, does anyone have like a water bottle? Yeah. Okay. If Rayleigh were to take the label off her water bottle, which you don't have to do, okay, but you've done this before, and you lay it out flat, that label is going to be just a rectangle, right? So just a rectangle's been wrapped around. This rectangle has been wrapped around the circle, and therefore it's the length of the circle. So circumference coming back into play. We'll do this Monday. We'll talk more about this Monday. This is how you do it. They give you a fancy formula, 2 pi r squared plus 2 pi r h. It's a handful to say. I recognize pi r squared though. That's the area formula of a circle. Why is there a 2 in front of it? Why is there a 2 in front of the pi r squared formula, Natalie? Yeah, 2 circles. Find the area of one, double it. Then this 2 pi r, this 2 pi r is just a fancy way of writing the circumference formula, because if you take the radius and times it by 2, you get the diameter. And if you do pi times diameter, that's the circumference, tells you how long the rectangle is. The h tells you how tall the rectangle is. And if you know how long the rectangle, how tall the rectangle is, you can multiply that and you'll have the area of the rectangle, and then you have all 3 sides. So a little bit longer to do. That's why we're going to do cylinders in their own section. We're not going to add them into the other ones. Yes.
What was the line thing? It was like rectangle is the length of the circle.
Oh, sorry, I didn't fill that in. You're right. The rectangle is the length of the rectangle is the circumference. Thank you. The circumference of the circle. The length of the rectangle will be the circumference, or the pi d of the circle. Okay. All right. So now each of you have, we're not going to do surface area today, so you can relax just a little bit. We'll start tomorrow. Each of you have either a rectangular prism on your table, on your desk, a triangular prism, or a cylinder. So what we're going to do now, before you come up and grab anything, let me explain. You're going to cut around the shape. You're not going to cut each individual square off or anything like that. You're going to cut around the shape, around the perimeter, you would say, of the shape. And then you're gonna leave everything else intact, and then you are gonna fold these up, and when you're done, on the top right of your paper, listen, shh, Frank. On the top right of your paper, it shows you what it should look like when you're done, or an example of what it looks like, okay? So you're cutting around it. Now, if you have the cylinders, be careful not to cut off the circles, because you're gonna want to leave those attached, and then when they're attached still, yeah, which means you have to like cut, stop here, go around, and it's gonna take you a little bit longer to cut it out. But then you can just fold those circles over. The cylinder is gonna be the toughest one to make. The rest of them are gonna be a little bit easier because of the straight edges on the, especially the triangular prism is probably the easiest one to do because it only has 5 sides. So with that being said, don't cut off your circles. Don't cut off your edges. Don't cut off each individual side. Leave them intact, cut around the shape and fold. Come grab scissors and tape and you guys can start working on this. Yeah, 15 minutes.